I'm now going to introduce an ancient method for generating a list of primes up to some limit n, called the sieve of Eratosthenes. Now, Eratosthenes was born in 276 BC. So this method, is over 2,200 years old, but it's very simple and elegant, and you could teach it to any child. Now, let's say, for example, we want to calculate all the primes up to 100, but this would work in the same way if we wanted to calculate up to 10,000 or a billion. It proceeds as follows. Assume all numbers are unmarked. Gray is unmarked. We start at the beginning, and if we find a number that is unmarked, we know it's prime. So we hit 2, and we say 2 is prime because it's unmarked. And then the second phase is, now we can eliminate all multiples of 2 because we know they're composite. So bam, we jump along and we eliminate all multiples of 2. Red means composite. And now we repeat. We step along from 2 to 3. 3 is unmarked, so we mark 3 as prime. And now we can eliminate all multiples of 3. And a really simple optimization is, notice 6 is already crossed off. We actually cross off the multiples starting at the square of that number. So 3 times 3 is 9. We start at 9 and mark all multiples of 3 as composite. And again, we go back, we jump along to 4. Well, 4 is marked, we know it's composite. Then we jump along to 5. We found an unmarked number. 5 is prime. Now 5 times 5 is 25. We go to 25, we mark off 25, 30, 35, 40, 45, and so on. Those are composites. We proceed forward until we hit 7. We know 7 is prime because it's unmarked. 7 times 7 is 49. We mark 49 and all multiples of 7 above it as composite. And now we move along until we hit 11. 11 is prime. And notice now, 11 times 11 is greater than 100, so we can actually stop at this point. We could have stopped at 10 even, because now all remaining unmarked numbers, if you'll notice, are prime. And we could, in one swoop, mark them all as prime. And that's the whole algorithm. It's so simple. And just to generalize how we do this, so we could write up a program to perform this sieve, is if we want to find all primes up to some number n, we first create a main loop. So we have for all numbers a from 2 to the square root of n. So notice here we stopped. When we hit 10, or if I showed it as 11, we actually stop because we have found all primes. So from 2 to the square root of n, we proceed as follows. If a is unmarked, then we know a is prime. And when we find a prime number, we mark all multiples of a off as composite. And that's it. So you find a number prime, mark off the multiples, go back to the beginning, increment a by 1. So we're on 2, then we go to 3, then we go to 4, 5, and so on. And when we're done, we have all primes. Notice here that this is also a loop. So we have a main loop for, and when we find a prime, this marking off of multiples is also a loop. So it's important to notice here that we have a nested loop. We have a loop inside a loop. Here is an example of this algorithm in action. I wrote in JavaScript below. If I put in 100, here are all the primes under 100. And if I put in 200, here are all the primes under 200. And if I put in 850, here are all the primes under 850. And below I have this program with a recording explaining how I set it up.